This is example 10.4 from Discovering Design with Chemistry. A chemist is decomposing KCl, potassium chloride, into solid potassium and chlorine gas. If he does the reaction at a pressure of 1.02 atm and a temperature of 24.3 degrees Celsius, what volume of chlorine gas will he make with 50 grams of solid potassium chloride? So this problem has a lot to unpack. Let's start with the beginning. We are told that he's decomposing this, which means we're starting with a substance and we're breaking it apart into things. Now, chlorine is one of our mononuclear diatomic atoms, so it has to have a 2, which means we need a 2 here to balance it, and then a 2 here to balance it. The first step of this problem is just to create a balanced equation so we can see what we're doing. After that, we can start looking at what else we have. We have some pressure. We have a temperature. If we're going to use any sort of gas law equation, we're going to have to modify it. So let's go ahead and do that. So we're just going to round this to 297.5 because of the precision and the original temperature. And then we're asked to find volume for the chlorine gas. So we want the volume of this one. And then they tell us that we have 50 grams of this. So all of these equations over here that we recently learned in this chapter have pressure or temperature or volume, but none of them have mass. So we're going to have to use the grams to do a little bit of stoichiometry to move into gas. We do have this one that has some moles involved that we can work with, and so that's the one that we will need, because we can convert grams to moles, and then we'll have all things that go in the same formula. So let's move over here for a second. So we have potassium chloride. So we have this and this. We've done this a lot, but for those who still need it. So if we add those up, that'll give us the how many grams per mole this compound has. So 39.10 plus 35.45, 74.55. So 74.55 grams per mole. So if we have 50 grams, let's go ahead and convert it over here. So if we have 50 grams, and we line up our numbers right, 1 mole, 74.55. This will tell us how many moles of calcium chloride, I don't know why I keep calling it calcium, potassium chloride that we have. So we're going to round this to only 3 significant figures, so 0.671. So that's how many moles that we have. So let's go back over here and record that. So 0.671. So that gives us another number. So we can use this information now, and we have a formula that has a lot of these, and it includes the volume that we need. So P V equals NRT. Actually, first, before we do that, we need to figure out how many moles of the chlorine gas that we have, because that's the one that we actually care about. So let's convert this, which is moles of the potassium chloride, into moles of chlorine. So because we have 2 and 1, we're going to take this number and we're going to divide by 2. We can also set it up the way we have done previously, like this: moles KCl times moles KCl moles Cl2. We have 1 for every 2. That way you can make sure that you're dividing or multiplying correctly. Alright, so we have 3 significant figures, so we're going to keep that. So 3, 3, 6. So we have 0.336 moles of chlorine gas. So this is the potassium chloride, and then 0.336 is the chlorine. And that's the volume we want. Now the temperature and pressure is the same for both because it's all the reaction is happening at the same time. Alright, what can we get rid of? We have a unit here that can go away, and a unit here that can go away. And then we're going to have to divide both sides by this, so that the volume is left by itself, which means that this also can be canceled out. So now we just have to put everything in the calculator. So 0.336 times 0.0821 times 297.5 divided by 1.02. So we get, and we have 3 significant figures as our limits, so 8.05. And the only unit we have left is liters, so that's in liters. So that is the volume of the chlorine gas that we can make with 50 grams of solid potassium chloride. That's the end of the problem, but let's talk about this for just a second. So we were given a problem. We recognized that it had a reaction that we could turn into a chemical equation and balance. And then we found pressure, temperature, a need for volume, but to use pressure, temperature, and volume to find anything, to work with things, we also needed moles, and we got grams. So before we could jump straight to using this formula that we've recently learned, we had to kind of wind back a little bit and do the stuff we did in the previous 2 chapters and go through some stoichiometry here to figure out how many moles of the thing we had so that we could put that into the equation with the other numbers and find the volume. So again, we're mixing new stuff with old stuff. That stoichiometry that we did in chapters 8 and 9, we are going to continue to be using that throughout other chapters.